Namaskar, I am Debmalya, teacher of the BGA school, Kolkata. I am a member of IIPT and this is my workshop. I am making some teaching aids for the children of school students so where they can enjoy and learn. So I am making some videos. This is a simple bulb and many more videos are there. Please watch my videos. Thank you. Welcome. This is my own made gold leaf electroscope. I have taken a plastic jar and I have connected with a screw, and this is an aluminium disc which I placed on the top. There I have put two aluminium foils which is acting as a gold leaf. Now today I am demonstrating the electrostatic property and how to detect the charge. First, this is the far I have taken and this is a glass rod. I am rubbing the glass rod with the far and you will find that this is acquired some charge. When I am bringing it close to the gold leaves are diverged, and when I am taking it away, this is converged. So due to this charged glass rod, the gold leaves are getting induced charge and they are diverged. As soon as the glass rod is removed, they are again back to the normal because the induced charge merge. So that means whenever I am bringing it closer, it is separating the charge in two parts. One, which is over the plate, is the bound charge because they are attracted by this glass rod charges, and other, the similar charge, are repelled. Now this charge in presence of glass rod is bound, they cannot move, but the opposite charge which is on the gold leaf plates, they can move. So they are called free charge. Now let me again charge this rod. This time I am bringing it closer, I am touching the plate. You can find that it is converged. That means all the free charges move away. Now I am removing this, again it is diverged. That means I have charged this gold leaf electroscope with the help of induced charge. You can see when I am again bringing it, it is closing. That means the charge of the gold leaf and this glass rod are opposite. So when I am bringing this, they are just neutralizing each other. You can find easily. So now we can decide that the charge in the rod and charge in the plates are opposite. Now let's see what we can say about this. I am putting some light over here. You can find there is no change in the divergence of the gold leaf. But when I am putting this UV light over here, you can find this, the leaf are converging. That means it is losing the charge. So why this is losing the charge? This is because the higher energy photons of UV light is incidenting on this aluminium surface and it is extracting the electrons. So that means this is the demonstration of photoelectric effect. Now let us conclude few more points. First, you have seen that by putting the UV light, it is discharged. That means definitely the leaves are negatively charged. Now I have charged the leaf with this glass rod, and we know that by induction it is always induced opposite charge. So by induction, if I am able to produce negative charge on the gold leaf, definitely this glass rod have positively charged. Now we have read in the book that when you were rubbing the far and the glass rod always get the positive charge. Here we have practically proved by rubbing this get positively charged. Number one, by inducing, when I am inducing this, we are inducing the gold leaf electroscope and it is getting negatively charged, and this negatively charged can be removed by using the high energy photons or high energy light. That is also the demonstration of the photoelectric effect. Now what happened if I change the metal? Let me change this aluminium sheet with copper. So now I have changed the aluminium sheet with my copper, and I am going to repeat the same experiment. Let us find what is the difference. Now I am again charging my glass rod. I am holding it near, I am touching it, so it is charged by induction. Again I am incidenting the normal light. You can find no change. There is no change in the divergence of the light leaves. Now I am bringing the UV light. You can find there is no change in the leaf. It's remained as it is. Now why this happens? Because this is, we know the property of the photoelectric effect. The energy incidenting on the surface should be higher than the threshold frequency. Now we can conclude this, that aluminium have lower threshold frequency, that's why this my UV light is able to extract the electron, whereas this copper plate have higher threshold frequency. So this UV light what I am using is not have enough energy to extract the electron from this copper surface. So this is also be noted. The photoelectric effect depends on the nature of the metal. If the metal have lower threshold frequency, we can extract the electrons, but if at higher threshold frequency, we need to put higher energy light. Unfortunately, I don't have any higher energy photons which can extract these electrons from the copper, but we can clearly demonstrate that aluminium and copper, we can conclude aluminium have lower threshold frequency, whereas copper has higher threshold frequency. So we have done the electrostatic charge, we have induced it, and then we have demonstrated the phenomenon of photoelectric effect. Hope you have enjoyed this experiment. Thank you. Welcome friends, this is an experiment I have made. I have taken this aluminium foil and make this as a small balls and poured into the glass. So, and I have put 2 spoons, I have filled the glass. It's very laborious job, you can find. Now when you are making this foil, must you remember it should be very tight. You must press it very tightly, and the size must not be very big. It should be a medium or very small size. As small it will be preferred, but to fill the glass with very small ball is very laborious, so I have made some little big ball also and some small ball also. Now I have made a circuit also, so which is a very simple electrical circuit. I have 2 battery and a bulb and 2 open wire, and if I connect this wire, the bulb is glowing. So this is a very simple open circuit. Now if you see that I have used 2 forks from my kitchen as a connector, and you can see the forks are on the surface of the glass. So 2 forks are not touching each other. It is the aluminium foil balls which is in between them. So we know that aluminium is a good conductor of electricity, but you can see that while it is connected, the bulb is not glowing. Now what happened if I put a lighter in it? You can see the bulb is immediately start glowing, and if I tick with the lighter, the bulb is not there. Again, you can see that when I pick the lighter over there, the bulb is glowing, and when I tick it, it is gone. So you can see what is the relation of the bulb to glow and the lighter. If I press it tightly, you can see the bulb is glowing, but if I tick, bulb is gone. Now when I am doing the lighter, the bulb is on. Again I am ticking, the bulb is gone. So Not only this thing, I have also done this experiment with this lighter, and now I am not using the flame. I have just taken out the lighter, and you can see when I am holding this tight, there is a tiny spark. Can you see the spark? Okay, now you can see the spark at the so this is actually a piezoelectric lighter, and it gives a spark of around 700 volt. You can find the tiny spark at the tip. There is spark, but it is not at the tip. It's difficult for me to adjust in my single hand. So you can find the spark. Now what happens if I hold this over this bulb? You can see again the bulb is glowing. See, and when I am ticking, it's gone. So what is the reason? So actually this is called Coherer circuit. These are the particle behaves as a coherer, and this is producing the electromagnetic wave. This lighter and this lighter are same thing, only I have taken out the nozzle and the gas part. I only use the spark. So this is used as electromagnetic wave detector. So what happens, these particles have a property, when the electromagnetic wave passes through it, it makes them in some orientation, and that allow the flow of current. And when I am taking, the orientation of the particles or the molecules is disturbed, so no further it is conducting the current. Not only these big balls, I have made the same thing with the small aluminium balls. You can find, I have made this thing with small aluminium foil. Every time you start the experiment, you have to adjust, because this is very sensitive circuit. First you have to adjust it to its basic starting point. The thing you can press and see it is glowing, and tick, it is gone. Now you can allow the spark. So when you give the spark, it will start working. Let me use my electromagnetic wave directly. So when I am holding this, you can find it is glowing, and when I tick this table, so disturb the circuit, the molecular orientation gone, it is no more glowing. Again I give the electromagnetic wave. Actually this is producing the electromagnetic wave, because these are the two poles you can find. And again when I am ticking and disturbing the orientation, there is no more current is going. So again I am producing the electromagnetic wave, and these tiny aluminium balls inside it again get oriented, and it start conducting the current through it. And when I am ticking this, it is no more glowing. So we have done with the fairly big size balls, and we have done the fairly small size aluminium ball. Now what happens, we reduce the size further. So let's see what will happen if you reduce the size further. Here a glass tube is there, and I have fitted with 2 screws, and what I have done, I have put some iron filings inside it. So I open the screw, put the iron filing, I adjust the screw to the size, so it just get full tight. This is the open thing, but I will make afterward, and I have already made another one. Here is that thing. So you can see there are 2 screws, and in between the dark black part is nothing but the iron filings. So I have taken some iron filings in between them, and I am again connecting with my circuit. You can find this iron filings are filled inside the glass tube, and we are going to use this electromagnetic wave. So this is not much sensitive. Let me use directly the spark. So this actually producing spark, and when you are doing, you have to adjust it. So first you make sure the bulb is glowing, and then you slowly you can turn it up by ticking. If it is not turning, just lose it little, because when it is tight, very tight. It does not allow the current to flow. So now I think it will work. So after adjustment, you are ready for the experiment, and you can find that again the same thing happened. So it's glowed and gone. That means I have to little bit adjust again, and again taking it is gone. So now again I am taking the electromagnetic wave part very close to it, and you can see it is glowing. Again I take it, gone. Again I am taking the thing very close, it is glowing. So basically when I press this lighter, it has small part which is called piezoelectric crystals, and then with the help of these piezoelectric crystals it produces the current which is around 700 volts. Inside this there is a crystals called piezoelectric crystals, and it produces a current which is around 700 volts, and that causes the spark. Now I am trying you to show the spark. So for that purpose I am directly connecting the two terminals of this. So I hope you will able to see the spark through it. This is the blank one what I am showing. This the air gap is there, sufficient air gap. I think you will able to see the spark. Can you see the spark? Okay, the bulb is gone. Start glowing. Can you see the spark? See, there is a spark is going between the two poles. That means it is producing the current, and which is around 700 volts or more, 700 to 900 volts. You can see the spark, and when it is passing through this coherer circuit get oriented due to this electromagnetic wave, and this iron filing which is in between become connected to each other. I don't know, it is not given in the properly that is there any bond is making. It is maybe temporary bond, or molecules are just connected to each other and thus make the circuit complete. It becomes very much conductor and it makes the circuit complete. Now when I tap the table, so this disturb the molecules, and it again become non-conductor, though it is iron filings. And again when I am tapping this, so you have to be very little adjustment should be there, because the gap is more, then it will not glow, and when your gap is small, you can find it is working. Whenever the spark is there, it is detecting the spark. So this, I find this is very interesting, and you can make this with very simple arrangement, because this is the aluminium foil which is easily available in your home, and we have used that fork and this type of lighters, and nowadays very easily available. So by combining this thing, we can make a very fabulous and interesting experiment. And also the best part of this can detect the electromagnetic wave. So actually this circuit is itself a detector, and it detects electromagnetic wave. So we can use it near the meter box or somewhere, and it can be whenever the spark or something is there, it can detect it. But the basic problem with this, because whenever it becomes conductor, to make it non-conductor you have to tap it. I have read in somewhere that initially this was designed to send the telegraph signal, but the basic problem that whenever it is becoming conductor, you need the tapping to make it non-conductor. So due to that disadvantage, this Coherer research does not go further, but this is a very nice and exciting experiment for me. I feel you have enjoyed this experiment. Thank you.